Okay, that's so much for catchments. Shall we talk about treatments? I've just picked out a couple rather than trying to go through every possible different treatment in music today. I've just picked out a couple to talk through the general principles and the way the auditor looks at things. And I'll talk about some of the things that are being checked on a couple of the others, but I'm more than happy to discuss or take questions on other treatments afterwards as well. So, but I'll just take you through wetland and bioretention because they're probably two of the more complex ones. So wetlands, this is a schematic of how music represents a wetland within the model. So you have water coming in, you have your inlet pond, you have your main wetland or macrophyte zone, which could be deep pools, might be macrophyte areas. And then you have your bypasses for high flow bypass and the overflow weir going around the wetland. And then if we look at the cross section, you've got obviously your permanent pool in the bottom and then the extended detention above that. So these are the various parameters that are in music and that we're looking to assess with the auditor. In terms of depth, I'll probably say two things. One is that at present there's no clear guidance on wetland depths in the South Australia music guidelines. The experience in Victoria and also other states has been that a lot of wetlands have been constructed with substantial water depths. The learning from that has been that these very deep wetlands aren't very good at supporting plants, and in many cases what we're seeing is that the plants just haven't survived, they haven't made it through establishment, or they just haven't survived in the long term. And we have a lot of wetlands that look more like open water bodies or ponds rather than actual wetlands. In the last round of the last two rounds rather of the Victorian music guidelines and wetland design guidelines and also the Queensland ones, what they've done is quite tightly restricted the depth range on wetlands, and they've recommended that the extended detention depth shouldn't be more than about 350 mil. They've also recommended limiting the permanent pool to something around about 400 mil, and the guidance on that is a little bit open. Obviously, a wetland isn't all one level. You've got shallow bits and deep bits and so forth. So there's a little bit of flexibility in exactly how that's arrived at. But on average, you'd expect to see that the permanent pool shouldn't be more than about 0.4 or at worst 0.5. And the EDD shouldn't be more than about 0.35. Now, we've introduced those checks into the auditor, but just be aware that at the present time, you don't have a design guideline to back you up on those at present, but it is definitely accepted best practice for the industry that we need to be moving in this direction. We do have some good local design guidances on the detention time. Your guidelines do recommend the 72-hour detention time, which is pretty much, I think all the southern states have that. The only variation is Queensland, where they accept 48 hours just because it's pretty physically difficult to get to 72 hours with the rainfall that they've got. But the principle there is that ideally you want 72 hours detention time to get good treatment of nitrogen and your other dissolved pollutants. So we check for that, recognising that if you've got retrofit situations and difficult spots you're trying to get wetlands into, that you might let that go down to as low as 48 in those situations. But in any new development, there's no good reason why that shouldn't be 72 hours. In the guidelines, what we've got is we've identified each of the parameters that are used in music. We've given a little bit of information on those, and then we've given an indication of where we've drawn guidance from. So whether that's a hard guideline requirement, as in the case of the 72 hours, whether it's just a recommendation or something you might need to check, or as I've mentioned, for the depth ranges, what we've done is set what we've called an internal guideline requirement. So the music modelling guidelines are recommending that, but there isn't, sorry, Gabriel, there isn't a design guideline to refer to at the present time. So that's the, I guess, the structure of how those are set up. If we apologies, Gabriel, I forgot to take it to full screen, and I'm going to go back to half screen again. If I just drop that back to half screen and you go back to the auditor, if you'd like to load the next example, the wetland, just this one. If you load in the wetland and just submit that, we'll just talk through some of the outcomes of that. By all means, feel free to follow along with these through the auditor if you want to. If you don't, that's fine. You can just watch what we're doing on the screen. That's okay as well. You won't lose anything. So what have we got here? It's flagged the high flow bypass, and it said this is 100. It's flagged the extended detention depth, and it's flagged the permanent pool. So in this case, what we've got is the high flow bypass. Generally, generally would prefer that is set to either a 1 in 1 year storm event or similar. Sometimes it's a 1 in 3 month or the 1 in 5 year that they're using, but generally we'd prefer that to be set to a 1 in 1 year event. The other possibility here is that is not restricted, but the overflow weir in the inlet pond is used as the overflow for the wetland. So you're using that as a control. So when the wetland has a lot of water coming into it, it fills up, water spills over the overflow weir. That's a valid and acceptable design approach. The other design approach is that the inlet to the wetland and to the sediment pond is actually restricted to limit flows coming in, so that any excess flows can be diverted around the bypass channel and not impact on the wetland vegetation. So there's two general approaches to that. So if they're leaving this at 100, you'd want to check with them that the way they're setting it up is that there is an overflow weir, and that any really high flows and high velocities will get diverted around that wetland if possible, and they won't be coming through the macrophyte zone. Alternately, you'll then see that they've got, this will be set to, a 1 year event, might be 1 or 2 cubic meters per second, and they'll be limiting those flows. This approach is what the guidelines that have been developed in Victoria are now pushing people towards. The only drawback of that approach is that if your wetland is not full and you have an event occurring, you can be causing bypass to occur when you may actually have capacity within the wetland to take those flows. So there is a case for having a system where you don't limit that high flow bypass and you rely on that overflow weir as the bypass mechanism for the wetland. That said, you do want to make sure that you've got those bypass conditions in place. In terms of depth, we've mentioned those, so the EDD and permanent pool, we are looking for those to be shallower, ideally to get good wetlands with good vegetation establishment. This is an area where you're likely to get some pushback from consultants, because this will be a change for some of them. They'll be accustomed to making these 1/2 metre deep and creating these wetlands that very quickly become ponds in a lot of cases. So this will be an area of ongoing discussion, I expect. I would encourage you to push on maintaining these depths as much as you can if you're with the authorities, and if you're a consultant, obviously do aim to try and design with these parameters if you want to have wetlands that are got good plants in them and good coverage and are working well, which really is what we all want to get to. Overflow, this is just a warning. If you've got proper design, if you've actually got a design for the weir, use that, obviously. And if the consultant says we've designed the weir and it's 5 metres, that's fine. I would accept that. The reason this flag is here is because if the weir is too small, if it's 3 metres and you're designing a 20-hectare wetland and it's humongous, music doesn't handle that very well. Basically, what it will do is it will just let the depth in the water fill up infinitely. And not drain out very quickly. So if you're dealing with very large wetlands, it becomes very important that you've set a sensible or an appropriate weir for that wetland. That doesn't happen too often. Most wetlands, if you've got it left at the 3 metre, it's probably okay. But I'd suggest that if you don't know what it is, It's better to be too big than too small, so just make it 10 meters or something like that. If you do know what it is, then use what's designed and accept that. Notional detention time, okay, so 41 hours. This is obviously a problem. They haven't even tried to get it to the 48 hours. You'd go back and ask them, hey, what's going on here? We'd like to see this at the 72-hour target, thank you. And if there's particular reasons, you might consider allowing that to be less than that. But otherwise, you'd be aiming for that 72 hours. And the other parameters we've got here, this is something that's not uncommon. These are basically parameters we expect to be the default that have been changed. So, weir coefficient, you haven't even bothered to change the weir width. Why would you change the coefficient? That's probably a typo or just a random change the consultant's made. We do see these from time to time, so this just picks up all those default parameters and flags them. When would you change that? When you've actually got a weir design, you're not using a standard weir, and the particular weir you are using needs a different coefficient, and then that would be a justified change in that situation. Number of CSGRs, again, no good reason for people to be mucking with those unless you're modelling an existing system and you're expecting that to underperform sort of normal or typical conditions, and you want to adjust it to represent that existing system that's got short circuiting and problems in it. Otherwise, I wouldn't expect to see that change very frequently. There is some guidance in the music manual. It gives some different shapes of wetlands, of treatment systems in general, and some guidance on how to choose that number of CSGRs. So if people want to change it, I'd refer to those shapes and say, is this representative of your actual system? Okay. Infiltration. Now, I think I've just talked through these, but I think I've actually got some notes on them. So infiltration for wetlands, usually what you want with a wetland is that it holds water, so that you have, I'll take this back to full screen. Usually what you want, usually what you want is that it does hold water, that it's got water in it for fish, for various creatures that'll eat the mosquitoes and so forth, and it keeps everything in it alive. That said, you might allow the upper reaches of a wetland to infiltrate as long as you keep your deep pools or your permanent pools intact. If you're just putting a wetland in existing soils, then you might allow for a very small amount of infiltration. You might say these are heavy clays, the infiltration's 0.5 millimeters an hour, something like that. But it's so low that the wetland will be fine, and we're just going to leave that as is. Otherwise, if you're lining it, then your infiltration will probably be practically zero, because you'll line it so that your infiltration's 10 to the -7 sort of thing. It'll be very low infiltration rates, and for all practical purposes, it's zero. If someone is designing a wetland with infiltration, and there is times when you might do that, then it does become important to look at the water level patterns or the inundation frequency for that wetland and make sure that it's not drying out completely for extended periods of time, and that the plants in the wetland will handle the particular conditions of that wetland. Ephemeral wetland design is fairly complex and requires a bit more thought, essentially, than a standard wetland. The other things to think about is where you've got infiltration, especially off something as large as a wetland, is to ask whether that's sustainable for the groundwater. Are you going to end up with a groundwater mound under the wetland? Does that pose risk for any adjacent infrastructure or slopes or anything like that? Do you have any potential issues there? Do you have salinity, etc.? And secondly, you might want to check that those pollutants that they're allowing to exfiltrate through the system, what we generally look for is that they're assumed to go into groundwater. Groundwater is a receiving water, so you should count those pollutants as having an impact on a receiving water. So they should be routed back into the system at the bottom end. In a sense, that kind of nullifies the advantage of representing the exfiltration, but it also, that's still useful if you're representing stormwater harvesting downstream of the wetland. You want an accurate read on what the yields are, but at the same time, you want to pick up what the total loads are reaching all of your receiving waters, including both the waterways and the groundwater downstream. There's also a set of advanced properties for wetlands. So, you've got the number of CSDRs, you've got the weir coefficient, orifice discharge coefficients, K and C star parameters for pollutant concentrations. 90% of models, 95% of models, none of this will ever be changed or shouldn't ever be changed. But there are occasionally reasons for doing it. We'll flag any of these parameters that get changed, so you don't have to wade through the advanced parameters in every single node of your model, checking each one of those to see whether the consultant's changed one of them. The auditor will flag any of those that have changed, and then you can go and have a look and see, have they given a justification for this? Does it make sense? Are we happy with that? Or do we ask them to go back to the default? Okay. So that's wetlands. I might pause for questions and then we'll take a 15-minute break just so people can run to the toilet or grab a cuppa or lunch or whatever you want to do. So are there any questions on the wetlands?
Dale, it's Dean Nobbs speaking.
Hi, Dean.
Has there been any work in South Australia regarding permanent pool depths? 350 mil doesn't sound like a lot to get through January, February, March without a lot of rainfall. Typically we don't get a lot of rain through there with high evaporation.
Through your summer. Yep.
Yeah.
Yep. So that's your permanent pool rather than your extended detention. It's worth keeping in mind that that's an average depth. So that doesn't stop you from having some deep pools in that wetland that are a metre deep or more, and then having some areas that are shallow. There's scope for more work to be done to look at that, what the ideal setup for that is. That could be made a little bit deeper if you think that that's needed to get through the dry periods. I'm conscious too that even within South Australia, you've got quite a variation of climate. If you're up in the hills, you're getting a fair bit of rainfall. If you're heading up north of the city, then it dries out pretty quickly, and you possibly do want to think about having some slightly deeper depths there to do that.
Thanks.
Yeah, so definitely systems should be designed to suit the context, and if you think that warrants a deeper permanent pool, what I would suggest is that you do the inundation frequency analysis, and there's another tool called the Wetland Analysis tool that's attached to the music auditor you can use to help you with that. I'd encourage you to do an analysis through that and show what those inundation patterns look like and how often it's drying out or staying wet, and that can be used as a bit of a guide to explain why it might be justified to make it deeper in some cases. So bioretention systems, similar to wetlands, you've got your extended detention depth. Instead of permanent pool, we now have the filter media of our bioretention, or our rain garden as our main system, and then we have plants in that growing up through the root zone, through the filter media, and then also extending through the extended detention zone. So important parameters for the bioretention are, again, depth, this time of the filter media, depth of the submerged zone if it exists, and then the specific properties of that filter media. So we are interested in the hydraulic conductivity, or the infiltration capacity of that filter media. We're also interested in the nutrient properties that it holds. So filter depth is a hard one. In terms of a minimum, the CRC guidelines suggest that it's at least 400 mil. Honestly, I'd say if you can make it 500 mil wherever possible. Certainly, some guidelines say 300, some 400 is a minimum. What we have seen in the field is that systems that are 300 or 400 mil deep are at high risk of just drying out really quickly and the plant's dying. You can add to that Dean's comment or question about the wetlands before that if you get fairly dry period through summer and not a lot of rain, things can dry out pretty quickly. That's doubly the case for your bioretention or rain gardens. So you do want them a bit deeper that if and where you can manage it. In terms of a maximum depth, that's a bit harder to set. There is no real maximum, but it's worth thinking about how deep are the roots practically going to grow. There's no point having filter media extending significantly beyond where the root zone will actually get to, because one, it's going to cost you more, and two, you're not going to get effective treatment through that area if you don't have any roots growing through it. So realistically, you're looking at 600 mil as 400 to 600 mil as a normal bioretention or rain garden. If you're doing tree pits, that's where we start seeing it go out to 0.7 through to a metre. Hydraulic conductivity, the CRC guidelines recommend a range of 100 to 300 mil an hour. Your design guidelines actually say less than 500, and then they recommend between 150 and 300. My recommendations are twofold. Firstly, that whatever you model should be less than what you actually design, to make allowance for some reduction in that conductivity due to clogging, due to compaction and uncertainty in the conductivity measurements themselves. And secondly, that you should try to avoid going too much towards the high end of that. We're seeing a lot of bioretention assets struggling due to lack of soil moisture retention within the media, and there's not a direct connection, but there's a general relationship that the higher your conductivity, the more sandy your soil is likely to be, the less soil moisture content it's likely to hold, and the more likely you are to have plant failure due to your system not holding enough moisture to keep the plants alive. The mitigating factor for that is that you can include a submerged zone, and the CRC is now recommending that you do that everywhere pretty much, that you can put a submerged zone in below any under drainage that the system has, and that has the effect of holding water in the bottom of the system so it's available for the plants. Now that can either be a gravel or a sand storage above a slow draining underlying soil like clay, in which case you might not bother lining it, because if the water goes anywhere, it's not going to go far. The plants will find it if it's in the clay around it. So I wouldn't have an issue with a submerged zone with no lining if it's in those kind of soils. If it's in sandy soils and you want a submerged zone to effectively hold water for the plants, then obviously you need to have a lining in it. So in terms of what we check with the auditor, it's hard to check for things like, do you have a submerged zone, or is your system lined or not? Because it kind of depends on your circumstances and your design as to what you're going to have. For filter depth, we've set a range of 400 mil through to a metre as acceptable, but anything more than about 600, I'd be looking at closely to say, well, hang on, why are they doing that? Does that make sense? Conductivity. Honestly, nearly every system we design, we just set it at 100 mil an hour, but we always design and specify for 100 to 200 or something like that in terms of what we ask for the media from the suppliers. We're finding a lot of suppliers in Victoria are struggling to give us stuff that's less than 200, which is what we'd really like. It's more like the 200 to 300 range, and the more freely draining stuff is usually what we get. You don't want it to be 10 mil an hour or 20 or something like that. You want it to be at least 50 and preferably more than 100. So the key thing is it's above that minimum limit. And if it's really high, just be conscious of that drying out potential, and that you're getting either soil moisture retained in the media, or you're getting it within a submerged zone to compensate for that lack of soil moisture content. In terms of nutrients, the CRC guidance is for the nitrogen content to be 600 to 1,000 milligrams a kilogram. The default in music is 800. We've had some feedback on these guidelines suggesting that could be as low as 400, and we've accepted that as reasonable. So that's now the range that we've set, that it's somewhere between 400 and 1,000. Really, you need to be confident that whatever material you source is less than what you're assuming in the modelling. And as long as you're doing that, then you're making a reasonable and a conservative assumption. So at the moment, the auditor will flag if it's not within the range of 400 to 1,000, and it'll also pick up for you if it's not that default of 800. But again, if it's in that range of 400 to 1,000, you would generally accept that value. Similarly for orthophosphate, music used to default to 80. It was then changed to 55. We're recommending for the guidelines that you have it within the range of 30 to 50. And that's, I guess, a little pragmatic. Firstly, recognising that nearly all the filter media that's being used is way less than 55. In fact, it's often less than 30 even. So if you model in that range, you can be fairly confident that your supplier will be able to give you material that complies with that or is even lower. So you'll be able to meet that requirement, but also meeting the 65% phosphorus reduction. You'll find if you leave that at 55 or certainly at 80, that you'll struggle to meet that with a bioretention in some cases. So that's, we're being conservative, but we're being unnecessarily and probably overly conservative, leaving that so high. So these are the ranges that we'll be checking. So EDD, we've set that to 100 to 300 mil. It's not a good idea to have bioretention systems exposed to very substantial depths of water for extended periods of time. They're designed to receive a storm event, allow that to flow through the system reasonably quickly, get filtered, get treated and passed on, and then for the system to dry out over a couple of days or a few days, and then for another storm event to come and wet the system again. They're not meant to stay wet for long periods of time. They're not meant to always be saturated. At the same time, we don't want them to completely dry out, but they're not meant to be saturated all the time. So for that reason, you usually don't want a really high EDD. That said, whenever we've looked at detention, extended detention in bioretention, what we've seen is that nearly always that drains out quickly. So if you have a bioretention sitting in a retarding basin or a detention system and you're modelling the extra depth of that system, that's what you'll find is that most of the time that will drain through the system really quickly anyway, and it won't necessarily be a problem. So it is a flag to say, be a bit careful, think about compaction and oversaturation and wetting, but at the same time, I wouldn't necessarily be worried if it's too high. The lower range of that is 100 mil, and one of the reasons for that is that with streetscape systems, what we see is people trying to do, they get clever and they say, well, we can only do 50 mil or 20 mil of extended detention. So they model that in the model in good faith. In practice, the contractors come out and they build it. That level looks much like the next one. They fill the gravel up to the surface, and before you know it, there's no extended detention in your system at all. In fact, it's not uncommon to see them overfilled. So we've set 100 as a minimum because that's enough to be obvious to the contractors that it's not meant to be at the same surface level as everything else around it, and you're more likely to get a successful system. Same check for the overflow weir as for the wetlands. Again, if in doubt, make it big, not small, and then that'll mean that any excess water building up on the system gets away freely. And then everything else in the bioretention, all the advanced parameters, we're checking that they're defaults, and most of the time we would expect you to be using defaults unless you're doing something weird and wonderful, if you're doing a tree pit or something else, and then you need to adjust some properties. But most of the time we expect they will be at the defaults. I've got an example again, if people would like to follow along. For some reason that keeps jumping back. I'll get the right one up. So if you'd like to follow along with me, the example is that Parafield Townhouse Surface Types one we've run previously, so you might already have that. I'll just find the right page and run that through. So what have we got? So just a reminder of what we're checking. They're the parameters I've just talked through. So what have we got for our bioretention? So our extended detention is quite deep in this case. So we'd go back and what I would suggest if you're getting something like this, firstly, you'd ask them why it's so deep, whether there's good reason. If they have a good reason for it, then the next thing I would say is, can you do an inundation frequency analysis on that bioretention and just show us that, you know, it's not staying for long periods of time with water levels that are very deep, that might put the system at risk. Most of the time, you'll probably find that it's fine. Filter depth, you know, they've got this one at 300 mil. These are kind of upside down by the looks of it. You'd perhaps question whether they could rethink that design and maybe be a bit smarter and do it the other way if possible. With this kind of depth, this system is going to be at risk of drying out and all your plants dying for sure. The first thing I'd look for is, have they got a submerged zone to back this up and support it? You know, if you've got 400 mil of submerged zone under that, that might be okay. Otherwise, you'd be pretty concerned about that drying out too much. Saturated hydraulic conductivity, again, 500 mil, very high. Combined with that filter depth, you could be almost guaranteed that the plants in this system wouldn't survive. So if you're deviating from the guidelines for one of these, you certainly don't want to be doing it for one of the other ones. So if anything, I'd be saying if your filter depth is so shallow, go to the other extreme and have some slow draining media that's got a lower conductivity and a higher soil moisture retention capacity. Exfiltration isn't necessarily a problem for bioretention. In fact, we encourage it. It's a good way of infiltrating some water back to the soil, back to the groundwater, and supporting base flow in urban areas. But it does get flagged, just as a reminder that you need to check that that's sensible and conservative for the underlying soils under the system. And also just to have a think about whether there's any other geotechnical issues that might preclude you doing that, whether there's infrastructure nearby, whether there is, you know, high groundwater or saline groundwater, or there's a slope that you might be putting things at risk there. So if you're doing exfiltration more than, you know, nominal amounts of 0.36 or 3.6, if that's 10 or 20, you definitely want to be looking very carefully at those geotech conditions. Okay. Bioretention is a big topic. Are there any questions on that before I move on? Oh, okay, we're all comfortable with bioretention. Excellent. Okay. So I thought it would be useful just to talk through what we're checking for a couple of the other treatment nodes. I'm not going to try and go through all of them today because there's quite a few, and it'll get quite repetitive. For infiltration systems, they're similar to a bioretention. The key difference is that an infiltration system doesn't have any vegetation. It can take the form either of a surface infiltration basin, which might just be sand or gravel, and then it's just allowed to infiltrate to the surrounding soils, or it might be an underground infiltration trench or soakaway, which get used probably more in South Australia than most other jurisdictions. They've been adopted for a bit longer thanks to John Argue's influence. For the infiltration parameters, there's not a lot of guidance around for these. It's worth saying. The EDD, we've recommended again that you're checking that it's within that sort of reasonable shallowish range, but again, there's no reason why it can't be deeper if there's a good reason for that. You just want to have a look and see whether that makes sense. Filter depth, again, we're checking that it's preferably on the shallow end, but again, you know, if you've got an underground infiltration trench that's 1 metre deep and it's 0.5 metre below ground or something like that, there's no reason why you can't have that per se. If it's an infiltration basin, I'd prefer that that's on the shallow side if possible. Once you start going beyond 350 or 400 mil, you need to start thinking about safety considerations for that. Is it fenced off from the public? You know, is it isolated? In which case you start to have other issues of it becoming an eyesore and that sort of thing. So you need to think about, you know, is this just an infiltration system in a nature strip or in someone's property, in which case you can't have that kind of depth, or is it, you know, a dedicated system in a park where you might accept higher depths? Sorry, conductivity shouldn't be there. This hasn't updated properly. apologise, these parameters haven't updated correctly. I had them updated. So the other thing to check, obviously, with the infiltration is that there is actually infiltration assigned. It has to be greater than 0 in this case, but then you do need to go and check that you've got suitable soil testing, and that the infiltration rates assumed are consistent with that. The other thing is that it becomes really important to give some thought to those issues around groundwater conditions, groundwater mounding. Is there potential for impacts on slopes and infrastructure? You really need to think hard about those if you've got dedicated infiltration systems. And again, we check all the advanced parameters are at their defaults as expected. So rainwater tanks are obviously something you're going to come across a lot. There's a few things here. One is that we've set the high flow bypass. We can't check for a specific range on this because it depends on how many tanks you've got and what the cumulative high flow bypass is for them. However, the guidance is that the gutters should be designed for the 5% AEP. And so what you can do is check that, if I got that right, is it 5? You can check that bypass is what you expect, and that the consultant's done the calculations to say what that 5% AEP is, and that the gutters and the flows into the tank are designed accordingly. The EDD, again, typically you want some EDD in that, and that might just be an air gap assumed at the top of the tank with an outlet pipe on it. So ideally it's sort of 90 or 100 mil, and it can be deeper, but if it's deeper, you would usually only do that if you've got an on-site detention storage allowed for within that rainwater tank. So it's providing that duplicate or double up roll. Part of it's rainwater tank and part of it is actually acting as on-site detention. If you're not doing that, then I would expect the EDD to be, 100 mil or something fairly nominal. So do look for that. Overflow pipes, 90 mils are sort of typical residential. Obviously, it's going to be more if you're in a commercial setting. At the moment, we're just checking that it's at least 5 mil, because if you start putting in a really, really small outlet, then you can get some problems with water just accumulating in the rainwater tank in the node in music and just building up. And again, there's no relief overflow for that, so it will allow the depth to increase basically infinitely. So you can have the model having water disappear from the system because it's all being banked up in the rainwater tank if you use a tiny outlet on that. So just be aware of that.
Dale, can I ask a question there?
Yep.
So we've had a bit of this with our Insight Water tool, a bit of discussion about that.
Sure.
With the orifice size.
Yep.
And there's been a bit of debate here that councils generally won't let anyone have anything less than 20 mil.
Yeah, okay.
For blockages.
Yeah.
So I'm just flagging, maybe we need to have a chat about that.
Yeah, okay. Yep. It might be worth, if that's the case, it might be worth us revising the guidelines to check a minimum of 20 mil in that case.
Yeah, all right, I'll note that. Cheers.
Yep, thanks, that's good. Yeah, it's probably worth saying too that that outlet should be a 90 mil if it's a normal design. If it's a detention system, then obviously you're doing orifice design for that detention system, and then they can be much smaller. But you'll have control measures in place to protect that orifice, hopefully. Reuse, it's again, these are the kind of numbers that we can't put a check in the auditor because it depends on how many tanks and what reuse and what you're using. There is some guidance in the guidelines on establishing reuse demands, but it's something that as an assessor, you really need to go and have a look and see what the consultant's assuming, how much reuse for toilet flushing, how much for irrigation, how much for cooling towers or whatever other uses they've got. Is that reasonable? Does it make sense? Have a look at the numbers that we've got in the guidelines. Is it suitable for the context? Because irrigation will change depending on where you are. So at the moment, the auditor will just flag these if they're in there. It'll give you a warning and say there's reuse here. You might want to go and check what's happening with it. But beyond that, we can't give you a rigorous check. It will flag if someone's using something unusual, like custom demands, it will flag it for you to draw it to your attention. And again, it will check those advanced parameters are all at their defaults. I guess coming back to Jude's point before about the summary report file, if someone's using demands, you need to document these. You can't just give someone a music model and go, here's our DA application, here's our music model, please approve it. You need to say what your assumptions are for those demands, how much for use per household, how much toilet flushing, etc. And this is the basis for it. You need to give some justification for what you're using. So I thought it useful just to talk more broadly about assessment, just in sort of wrapping up the session. It's worth saying, well, why are we here? What are we looking for? And really what you want in assessing a music model is to satisfy yourself that it's going to meet all the planning objectives and requirements that are set, the 80, 65, 45, etc., 60, 45, sorry. That the systems are actually going to effectively protect the environment into the future, that they're sustainable and that they're durable. There's no point in having, we've ticked the box on the music model, but you've designed something that we all know is going to fail. At the end of the day, we need assets that are going to work and that are going to last into the future. In terms of assessment, it should be fair and it should be objective. Basically every developer, every consultant that comes to an authority should be able to have a reasonable expectation that they'll be assessed on the same grounds that every other consultant and developer will be assessed. So the idea is that there should be a level playing field. We need to recognise that modelling is not an exact science. So while we need to have some clear expectations, we need to have some rules and some requirements, we need to have some really clear boundaries, but at the same time we need to bring to it a bit of common sense to the extent that it's common, and some judgment to deal with those grey areas where the answer to something is it depends, because it depends on your context, and in different contexts you may use a different number, you may take a different approach. And at the same time, we also need to make allowance for that innovation, for new types of systems, for different ways of doing things to develop and evolve over time. These guidelines are a snapshot in time. In 5 years, they'll be out of date. So if someone's doing something that we didn't envisage in the guidelines, we need to take that into account. So on the one hand, we need some clear rules and checks to keep things in reasonably consistent. On the other, we can't replace having an assessor who knows what they're doing, checking through these models. So I'll just pull up that. Thanks, David. Appreciate your time coming to join us. I've covered all the main stuff, so I'm just taking them through the assessment and then just talk about some of the future plans as well. Thank you. Okay, so the way the auditor is structured is that it's checking things that are guideline requirements, things that are what we call the internal guideline requirements, and then the recommendations. So anything that's a guideline requirement, we'd say that's a red flag, stop. We really expect to see these complying most of the time. You shouldn't be varying these very often, and you need a good reason if you're doing it. Internal guidelines are somewhere in between. You'll probably vary from these more often. There needs to be a bit of judgment on whether that's suitable or not. You need to think hard about whether you still have a sustainable water sensitive urban design asset with these changes proposed. How does it balance out with all the other things? If you've got that filter depth that's too shallow, how are you balancing that up with a lower hydraulic conductivity, with making sure the system's getting enough moisture in it? If you've got a submerged zone, etc., how are you balancing things? You're not just taking everything to the extreme. Finally, there's recommendations where it's just general principles or typical or common ranges, but there will be situations where things will vary from those. So from an authority reviewing point of view, you need to be mindful that you have to expect some variations from those. You're not going to get a music auditor report that's completely clean and has green and ticks all over it. You're going to get a few things that get flagged with justifications, and you should be able to work through those with your consultants and have a look and say, yes, this is a reasonable assumption in this case, we'll accept that. Okay. What the auditor won't do is it won't check the catchment and drainage layout that things have actually been put together in a way that makes sense. It won't check that your catchment areas actually match the design plans, and it won't check the dimensions on your treatment systems actually match what you've got on your design plans as well. Another important one that often gets missed is you need the whole catchment in the model, even if your development's only half the catchment. If the upstream catchment's impacting how that wetland operates, if there's upstream treatments, they need to be in the model as well, because that will influence how the systems operate, whether they get wet too often, whether upstream flows are diluting treatment. All of that needs to be taken into consideration. It may mean you have to do some mathematical gymnastics to calculate what your load reduction requirements are for your catchment versus what's coming out the outlet. You can't just use the treatment train effectiveness, but it is important that those upstream catchments are considered. It won't check your impervious fractions, and this is important because they're probably the most influential parameter in the whole music model. Besides obviously the catchments and so forth, the impervious fraction will have a big impact on your flow and consequently on your loads coming through. So if there's one area where it's worth spending a bit of time getting your model accurate, this is where I'd put it. Trying to get those estimates as good as you can for what is the impervious fraction of those catchments. The auditor won't check that you've actually put your treatments in the right order. If you followed those principles of primary treatment first, secondary treatment, tertiary, have you got your sediment basins and your GPTs and your swales upstream, your wetlands and your bioretention and so forth downstream. If someone puts them back to front, and it does happen unfortunately, the auditor won't pick that up, but as an assessor, you definitely want to be flagging those kind of issues. I just flag also that at present we don't check gross pollutant traps and we don't check generic nodes, simply because there's so many different potential gross pollutant traps. It's difficult for us to have a sensible checking of those, so you do need to have a look through those yourself. And the generic node really could be getting used for pretty much anything. We mostly use it for pumps and diversions and the like, but we can't really check that sensibly. Okay. Coming back to Jude's point about submissions, we would suggest the following is provided: that you've got design reports and plans, that there's a summary of all the model inputs and key results given, even if it's a 1 or 2 pager or something, but just summarize everything important for an assessor, make their job as easy as you can. You should spell out what climate's being used. Present the results as the treatment train effectiveness for the overall development to the outlet, and you should have the model itself and ideally the summary report submitted. And finally, any variations or deviations, put in a justification and an explanation. And as the industry gets up to speed on this and cottons onto it, I think as authorities, what you can expect to see is that the consultants will run the auditor themselves. They'll see what's getting flagged. They'll provide a justification, and then you can review that and go, yep, happy with that, need to question that. And then you can reduce that back and forth between the consultants and the authorities as much as possible. And our experience has been that people are quick learners. They want to get their stuff through quickly, and they'll adjust and accommodate, and then that makes the process easier for everyone. I mentioned versions initially. At the moment, we're supporting South Australia Music Guidelines 2020, assuming that we get them out this year. We support version 6.3 and by default 6.2, simply because there were no changes between the two versions. At present, we're not supporting earlier versions, but if there is significant usage of those earlier versions, we could do that. Our intention is that Music X will be supported within the next 3 months, hopefully sooner, and that we'll be able to have both 6.3 and X running simultaneously. Moving forward into the future, our intention is that we'll have the current and the previous version of whatever guidelines you have and whatever versions of music that exist supported, because we appreciate not everyone is upgrading immediately. And the other thing I'd expect is that we will have climate templates for other regions and other councils coming through, and we're more than happy to add those in so that they can be included in the checks. other plans and intentions. So I guess firstly, for anyone that's not aware, eWater have released Music X, which is the next version of Music. It's nominally up for production. It's out of beta. It's available for people to access and use. It's based on the source platform. It implements everything within it that was in version 6.3 pretty much. There's a couple of exceptions, but it's got most of the functionality. At present, there's not really any new functionality. There are some new ways of looking at results or extracting results or selecting what results you get. At present, we're not using it for production. There's a couple of things that need to be sorted out for it, but we anticipate that in the coming months, eWater will get all that sorted, and we'll start transitioning across to use Music X, and the industry will start doing that. We're probably not quite there yet, as my current assessment of the situation. My advice for consultants and authorities at present is to continue using version 6.3 until everyone's happy with version X and what's coming through it. And ideally, we've got the auditor running for you as well. Just to make you aware, I had that question earlier from Dean about wetlands and potential drying out. If you do need to look more closely at wetlands to see whether they're too wet because they're getting too much water too often, or whether they're potentially drying out over summer, you can use the Wetland Analysis tool, and that takes a flux file from Music. You can export the flux file from a wetland node. So I'll just show you quickly. If you turn on the fluxes and then tell it to export a flux file, you can actually upload that to the Music auditor. Oh, I've killed my full screen. That was silly. Okay. Let's get that back. You can upload that file to the Wetland Analysis tool, which is comes with the Music auditor. And then you can get an inundation frequency graph and have a look at, is the system too wet too often? Is it likely to drown the plants? Is it drying out completely for months at a time? And do we have issues at that end of it? And it allows you to then select the plants so that they can survive the conditions better, and potentially adjust tweak the depths in the wetland to get better outcomes there. So at the moment, we're not requiring you to use this through the guidelines, not because we don't think that it's good to start doing this level of design for wetlands, but mainly because at the moment, Music is not real good for doing custom stage storage discharge relationships, and we're finding people in Victoria having a really hard time navigating that and getting their models set up to do that well. So I'm reluctant to lump that on you at present until that's working more effectively. But looking ahead, what we envisage is in the future, we'll have this second level of checking that you can do on your wetlands to make sure that the water level patterns are suitable for the plants and they're not too wet or too dry.